Okay, continuing with our discussion of quadratic functions here in standard form, let's say we're asked to sketch the graph of y equals negative of the quantity x plus 2 squared plus 4. How will we handle that? Well, one thing that we need to do right away is to identify a, h, and k in this setup as per our form right here. And actually, I'm going to take this form, I'm going to put it right next to our example. Let me shrink this down just a little bit so we can make everything look about the right same size here. Okay, so what could we tell? Well, one thing that we can tell right away is that we're going to say that A is equal to negative 1. And that's going to change the way that we view our graph, because what that's going to indicate is a reflection. The graph, the parabola, will open down. That says reflect, trust me. H. Well, in this case, H is not positive 2. In fact, it's negative 2. Why? Well, that's right. If we think about this equation in the form of y equals negative 1 times x minus h, the only way to get x plus 2 is to make it x minus negative 2. Right? Plus 4, so now we also know that k is equal to positive 4. So if we use this information to help us, then we're going to identify the location of the vertex to be the point negative 2, positive 4 on our graph. Okay, so that's the first bit, identifying the vertex. The axis of symmetry is nothing more than the vertical line that passes through the vertex. So in this case, our vertical line is always of the form x equals something. And in this case, if it's a vertical line, it must pass through that vertex at negative 2. So x equals negative 2 is the equation of the axis of symmetry. Well, what else could we tell right here? If we're not as familiar with what A is going to do, we know that it means that, in this case, if we go to the left or right by 1 from the location of that vertex, we're going to go down 1 point. So just for illustration point, I'll do this right here on the graph. If I were to plot some points, negative 2, positive 4 is the location of our vertex. Okay, there we go. Negative 2, 4 is the location of our vertex. A equals negative 1 means that if we go down, go to the left 1, we need to go down 1. And if we go to the right 1, we need to go down 1. So our graph might pass through these points. But we can also use x and y intercepts as aids in getting us these coordinate points. So let's find that. How do we get an x and y intercept? Well, remember that you get an x-intercept by setting y equal to 0 in your graph. And this particular form that we have for our equation is actually really handy, and I'll tell you why. If we set 0 equal to the negative of the quantity x minus 2, x plus 2 squared plus 4, then we can add the quantity x plus 2 squared to both sides to get x plus 2 squared equals positive 4. And if we take the square root of both sides to isolate our x term, then x will equal plus or minus the square root of 4. So subtracting 2 from both sides gives us x equals negative 2 minus 2, or x equals negative 2 plus 2, which means that we're either going to get negative 4 as the x-coordinate of one of our x-intercepts, or x equals 0 as the other. So in other words, this graph must pass through points like negative 4, 0 and 0, 0. Okay. Y-intercepts, a little bit easier. In a y-intercept, you set x equal to 0. So let's set x equal to 0 in our equation and see what happens. If we set x equal to 0, y will equal the negative of 0 plus 2 squared plus 4. Well, y will equal negative 4 plus 4, which is to say 0, and we've already identified that point as 0, 0. So let's go ahead and plot these points on our graph here so we can see them. Negative 4, 0 will be here, 0, 0 here, and we're already getting a fairly clear picture of what this graph is going to do, but let's go ahead and plot this graph anyways. No, I don't want you to leave there. Let's plot this graph here. Hold on, graph. Sometimes it likes playing, other times not so much. There it is. Okay, so this is the shape of our graph. And we can see exactly what's happened right here. Our graph indicates the coordinate points that we had. Our vertex at negative 2, 4. Our axis of symmetry along the line x equals negative 2. X-intercepts at negative 4, 0. X and y intercept both at the point 0, 0. And our graph generally opens downward due to that negative in front of the function. Okay, so you can see that this form is actually really useful for all these things that we want to do. So the next question in our next video might be how we get there in the first place.